You know, there are viruses that make you sick, and then there are viruses that are in a whole other league of dangerous. Today, we're going to be decoding one of those, a virus that the World Health Organization has on its priority threat list, one with a truly terrifying reputation, Nipah virus. Take a look at this number, 75%. In some outbreaks, that's the percentage of people infected with Nipah virus who don't make it. A case fatality rate that high? Well, it's not just a statistic. It's a blaring global alarm bell. So understanding this virus isn't just some academic exercise. It's absolutely critical for all of us.
But the real question is how, right? How does this microscopic thing achieve such devastating results? How does it manage to turn our own immune system, our own bodies, completely against us? Well, that is exactly what we're going to decode together.
To really understand an enemy like this, we've got to treat it like a criminal investigation. And the first step is to profile the killer. So let's take a look at the official rap sheet for this virus.
Okay, so first off, Nipah, or Nipah as it's called, is a biosafety level 4 pathogen. That's the highest, most secure classification there is. Basically the maximum security prison of the virology world, save for the absolute most dangerous agents. It first popped up on our radar back in 1998, and here's the kicker. Even today, there are still no approved vaccines or specific treatments for humans.
And here's where it gets more complicated. This isn't just one single villain. Scientists have actually identified two major branches of the virus family tree. There's the Malaysian strain, Niv-MY, and the Bangladesh strain, Niv-BD. And as we're going to see, these two versions are very different, and that difference can be a matter of life and death.
So how does the attack even start? I mean, to be a killer, a virus first has to get inside our cells. It's got to get past the first line of defense. And let me tell you, Nipah is an absolute master of the break-in.
The best way to picture it is like a super specific lock and key. Our cells have these protein locks all over their surface, right? And Nipah has evolved the perfect key. It's this specialized tool on its surface called the G-glycoprotein. When that key finds the right lock on one of our cells, boom! It unlocks the door and lets the virus right in. And it's incredibly specific about the locks it picks. Its favorite targets are proteins called ephrin B2 and ephrin B3. And the problem is, these are found on really critical cells, like our neurons and the cells that line our blood vessels. The virus even uses another molecule, heparan sulfate, almost like a grappling hook, to latch on and help it move from cell to cell. It's disturbingly efficient. But you know, just getting in the door, that's only phase 1. Once it's inside, that's when Nipah unleashes this sophisticated arsenal of secret weapons. And they're all designed to do one thing: completely shut down our body's internal security system. And this isn't a brute force attack, it's pure sabotage. The virus uses this toolkit of what you could call saboteur proteins. Their names are P, C, V, and W. Think of them like a team of covert agents. Their whole mission is to dismantle our immune response from the inside, before our body even has a clue it's under attack. So check this out. Here's the play-by-play of the heist. An infected cell, doing what it's supposed to do, tries to sound the alarm by sending out signals called interferons. But Nipah's saboteur proteins are already waiting. They intercept the messengers that carry that alarm, these proteins called stats, and they physically trap them. The alarm call is silenced before anyone can even hear it.
It's a shockingly effective two-pronged attack. On one hand, the viral proteins directly block the alarm pathways, and on the other, they literally round up those stat messenger proteins and lock them away in these little viral-made prisons inside the cell. The result? The immune system is left completely blind and deaf to the invasion.
And just when you think it couldn't get any more clever, there's more. Another part of the virus, the M protein, actually gets in on the action too. Its job is to hunt down and destroy one of our own proteins, called TRIM6, which is yet another part of our body's alarm system. It's just a relentless, multi-layered assault on our defenses. So what happens when a virus can just run wild inside your body, completely invisible to your immune system? Well, the result is a trail of absolute destruction.
Maybe one of the most frightening things about Nipah is something called neurotropism. In plain English, that means this virus has a dangerous attraction to our nervous system. It's one of the few viruses that can cross the super protective blood-brain barrier, letting it invade our body's command center and cause severe, often fatal swelling of the brain.
And this is not a theory. We have the data. Look at the 2018 outbreak in Kozhikode, India. The numbers are just brutal.
A staggering 83% of patients suffered from that severe brain swelling, encephalitis. 82% had life-threatening fluid in their lungs, and for a quarter of them, it attacked the heart muscle itself. This is a full system assault.
All right, so when you have a killer this effective, you have to start thinking bigger. We're not just talking about a single patient anymore. We're talking about a potential global threat, which means we have to play detective and figure out where this thing comes from and where it could go next.
So, where does it hide out in nature? The trail leads back to these guys, Pteropus fruit bats, which you might know as flying foxes. They are the natural reservoir. They can carry the virus across huge areas of South and Southeast Asia, often without even getting sick themselves, making them a silent, constantly moving source of a very deadly threat. What's really wild is how this virus adapts its game plan. In the first outbreak in Malaysia, it jumped from bats to pigs, which then infected farmers. In Bangladesh, outbreaks are often tied to people drinking raw date palm sap that's been contaminated by bats. And more recently, in India, we've seen it spreading directly from person to person. It's a master of finding a way. And this takes us right back to those two different strains we mentioned. Remember? Well, this is where that genetic difference becomes a terrifying reality. In the Malaysian outbreak, the fatality rate was around 40%. Horrific. But look at the outbreaks in Bangladesh and India, where the other strain is dominant. The death rate there jumps to over 70%. The difference is just staggering.
And that's why the investigation is so urgent. Scientists are in a race against time because there are still these huge gaps in what we know. They're working flat out to develop vaccines and treatments, to figure out exactly how it breaks through the blood-brain barrier, to pinpoint what in its genetic code makes one strain so much deadlier, and crucially, to try and predict where the next spillover event might happen.
So all of this leaves us with one final and pretty sobering question. We have a virus with an incredibly high fatality rate. We know it can adapt to spread between people, and its natural host, the fruit bat, lives all across the globe. All the ingredients for a potential catastrophe are there. So the real question isn't if a virus like Nipah could spark the next pandemic, but whether we're going to be ready when it does.